All right, so let's look at this second example, analogy. Here, as we've said before, in addition to exploring semantic change, word embeddings allow us to explore semantic structure. And this is because word embeddings exhibit a property of linear combinability, so that if you add and subtract words, you get other words. And these new words actually make sense. So again, the classic example of king minus male plus female equals queen. All right? We call this the semantic algebra, and this provides an extremely useful insight into culture. So here are some analogies in semantic space that are present, and this is using PCA to project these words. But you can see that there's a consistent opposition between these words that form analogical pairs. So China is to Beijing as Russia is to Moscow, as Japan is to Tokyo. So that's describing the relationship of being a capital in a country. And you know, this is quite brilliant, actually, quite wonderful to see this, because that really gives grounding to the idea that this methodology is surfacing real relationships, not just meanings, but relationships between things, which is really quite profound. Here's a way of visualizing how this process works. So what you see in those color bars there, those are vectors, and the red and blue indicate the presence, high presence or high positive and high negative values of concentrations in the feature. And you can see that when you take man, king, and man and woman and combine them in the way that you have above, that you'll produce the vector king, man, and woman, king minus man plus woman. Now the idea here is that in mathematical terms, if you actually perform this operation, you're going to end up with a vector which is not identical to queen. You're going to end up with a vector that you're going to find the closest vector to, and if that closest vector is queen, then you say that it actually is queen, or that you've actually solved the analogy. And it works something like this. So on the left is what an analogy is in classical terms, and this goes back to Immanuel Kant, who talked about an analogy as I think he talked about it as a perfect relationship between non-identical things, something along those lines. But the point is that it's the relationship not between A and C and B and D, but it's a relationship between a relationship. That's the key idea in an analogy. An analogy is a relationship between a relationship. So A and B have a relationship, C and D have a relationship. So what is the relationship between those two? If they're identical, then you have an analogy. So the way that gets translated, the A is to B as C is to D gets translated, is in the following way. You take B and you subtract A and you add C to get D. And I've put the plus and minus, plus and equal signs on the diagram to give you a sense. And you can see that there's a counterclockwise movement from the top. You go from B minus A, and then you add the C, and then you get to D. And so whenever you think of an analogy and you want to construct a mathematical formula to compute that, that's what you would do. And we're actually going to do that in our code walkthrough, show you how that's actually done.